What's up, guys? Welcome to War Room AI. In today's show, I'll talk about edge computing. What is edge computing? Edge computing is a distributed computing paradigm. Distributed computing paradigm. That is the first things that we have to keep in mind. It's a paradigm for distributed computing that brings computation and data storage closer to the location where it is needed to improve response times and save bandwidth. So, what are the goals? To bring computation, that is CPU power, and data storage, that is hard drive, so memory, closer to the location where it is needed, closer to the user. What are the benefits? So the benefits on the one hand is that it improves response times. So there are, because edge nodes, or let's say edge nodes are closer to the user, the latency, the communication latency, so the time for package to arrive from the edge node to the devices is lower. And on the other hand, it saves bandwidth because data doesn't need to go to the cloud. Only a smaller percentage of the whole amount of packets go to the cloud. So we are reducing the unnecessary traffic to the data servers. This new distributing computing paradigm is changing the internet nowadays, and it will change in the future, and it presents some challenges. The first challenge is privacy and security. Next one is scalability, reliability, speed, and efficiency. So those are things to keep in mind when designing the architecture of edge computing. What are the applications for edge computing? Some current applications that are quite popular are cloud gaming. For instance, for YouTubers that are gaming, or for normal people gaming, but you can see the YouTubers that are gaming, and so they are using Twitch, and then you can see them playing a game. Then the next application is connected and/or autonomous cars. So cars are becoming more and more connected. They have more and more electronics, and more traffic data is generated by a car connected to a data server, to the cloud. Another thing that is evolving very much is Industry 4.0. So machines are connected to the cloud to monitor the processes and to optimize them in order to get a higher profitability. And the last point, also very important, is smart cities, buildings, and homes. So our buildings, our homes, our cities are becoming smarter. They are equipped with more and more sensors that generate data, and with more actuators that can optimize the efficiency of the cities, buildings, and homes. I'll show you the architecture of edge computer together with data servers and the end devices. So on the top we have, let's start from the bottom. So we have devices such as, in this case, a smartphone, a tablet that is connected to a base station, radio station. In this case could be 4G, or 5G radio stations, and then there is communication between the end devices and the radio station. Then those devices, instead of communicating directly the whole traffic to the cloud, we put here in the middle these edge nodes. This is new. This layer is new, where we put edge nodes that are closer to the user. What is the purpose of using these edge nodes? So for service delivery, for computing offload. So instead, if those tasks can be run locally here, we don't saturate the servers behind. For IoT management, so because the number of devices is growing exponentially, so the IoT of things, so the IoT, the Internet of Things, is going to generate a lot of data, and in order to be able to handle all that traffic, we need edge nodes locally, also to reduce the latencies. And then another important purpose is the storage and caching. So when we have the local storage here locally, we have a local copy of the data. We don't have to ask for the data here in the server, so we don't saturate with extra traffic between the edge node and the cloud. So we store the data here locally, and then we are able to run the processes with the data and the processors here, and run processes for the end devices to provide services. Here there is the same kind of architecture. So the architecture is based on 3 layers. So we have the cloud with the data center servers, then the edge layer with the edge nodes, and then the end devices, many Internet of Things devices. So in the cloud we have data centers. On the edge layer we have the edge nodes that can run real-time data, so they can do real-time data processing, basic analytics. So they catch the data, they have a local copy of the data, of the status of the devices, and another important data, do some buffering and optimization, and then machines can communicate each other through the edge nodes, and they don't have to communicate from machine to machine. They don't need to reach the data center and go back to another device, and that reduces the latency. One question is, which kind of devices? We talk about the Internet of Things. Which kind of devices are connected to the edge nodes and to the cloud overall? So we can find here some examples. This is like in a factory. Probably you have some kind of sensors, for instance, about the temperature or the speed of a motor or whatever. The other one is connected to our autonomous cars. Here again we have a factory, and then we have a robotic arm doing some kind of logistic process. Then renewable energy. We have a windmill, and we can monitor the speed of the wind and the turbine and the energy and power generated in real time. Same here with the solar cell. And then we can also monitor the transmission lines, the electricity that is being provided to the different buildings and consumers, and the water consumption as well. Good. So these are typical applications for the Internet of Things. Here's another example with other applications. We have here, so in a hospital, we have devices that show us like the electrocardiogram, so the heartbeats of patients. Then we have smartwatches and smart trackers monitoring real-time different, so our stress, our temperature, our heartbeat rate, and then the typical applications, laptops, smartphones, and tablets. Connected devices, connected smart cars, autonomous cars, and drones. And then the gaming industry with, for instance, the Xbox or PlayStation, and then the VR headsets, for instance, the Oculus Rift from Facebook, and so on. So to give you some, so that you can imagine why it's important this extra layer, because maybe you don't understand, but is it really necessary? It's not doing the same function as the previous data servers. Why do we need these extra layers? It's a problem of scalability. So the number of devices, IoT devices, is growing exponentially, and we will have billions. So nowadays, so we are 8, 9, 10 billion people on the world, and we will have as many devices or more running that are connected to the cloud. And if we have billion of devices connected only to thousands of machines, big data servers, the capacity of the data servers is not enough. And in order to optimize that, the best solution is to distribute the computer power and the storage where the user needs it. So to put it closer because of the benefits. Which were the benefits? To improve the response times, so reduce the latencies, and to save bandwidth. So don't transmit all the data to a server which is farther away. We just need to transmit it to a local edge node, so that that the network doesn't explode because of so much data traffic. So here we will have, so let's say, so in the edge, on the IoT or end devices layer, we have billions of devices. On the edge nodes, we have millions of edge nodes, and on the cloud level, we have thousands of data centers. So that is a rough idea. And finally, I have this image describing some, so the main functions of the first top layers, the cloud layer. So it's for big data processing. So we analyze the processes, is to optimize the processes. So the business logic is a more an abstract level. And then the data warehousing. So this is more a strategic layer, a strategic and abstract layer. And then the edge layer is more concrete and more on the operations side. So this is to run the operations, and this is more strategic. What are the functions of the edge layer? So real-time data processing. It is deployed at source or on premises. For data visualization, basic analytics is just basic analytics. The other one is business logic. And then data caching, buffering, data filtering and optimization, and then machine-to-machine communication. I think so. that is all. I hope you liked the video.